What if the most brilliant mind of our cosmos, Carl Sagan, already saw 2026? We're on the cusp of astronomical breakthroughs, from exoplanet observations to deep space probes, and many of these echo Sagan's profound cosmic predictions. Could humanity's next giant leap into the unknown have been laid out by him decades ago, waiting for us to catch up? Welcome to Echoes of Cosmos. Carl Sagan died in December 1996. He never saw the first confirmed exoplanet around a sun-like star. He never witnessed the Hubble Deep Field. He never lived to see the detection of gravitational waves, the imaging of a black hole, or the launch of the James Webb Space Telescope. But here's what's extraordinary. When you read Sagan's writings, when you watch his lectures, when you dive into his scientific papers from the 1970s, 80s, and 90s, you find something uncanny. He predicted much of what we're discovering now, not with mystical foresight, but with rigorous scientific extrapolation. And in 2026, we're living through a moment Sagan would have recognized instantly, a convergence of technologies, missions, and discoveries that he spent his entire career anticipating. Let's explore what Sagan predicted, what we're discovering right now in 2026, and how eerily accurate his cosmic vision truly was. The year 2026 is turning out to be extraordinary for astronomy. We're not just observing the universe, we're fundamentally reshaping our understanding of it. The James Webb Space Telescope is now in its fifth year of operation, and the data keeps getting more stunning. We're seeing galaxies that formed just 200 million years after the Big Bang, pushing the boundaries of cosmic dawn even further than we thought possible. The European Space Agency's PLATO mission, launched in late 2026, is beginning its hunt for Earth-like planets in habitable zones around sun-like stars. Not just any exoplanets, but worlds where life as we know it could potentially exist. NASA's Europa Clipper is well on its way to Jupiter's moon Europa, scheduled to arrive in 2030. Its instruments will analyze that mysterious subsurface ocean, searching for conditions that could harbor life. The Vera Rubin Observatory in Chile has begun its legacy survey of space and time, photographing the entire visible sky every few nights. It's detecting thousands of new asteroids, supernovae, and transient cosmic events, a real-time movie of a changing universe. And perhaps most intriguingly, the SETI community is buzzing with new algorithmic approaches to detecting technosignatures, not just radio signals, but industrial pollution in exoplanet atmospheres, megastructures around distant stars, or laser communications between civilizations. Each of these developments represents a fulfillment of predictions Sagan made decades ago. Let me show you how. In 1980, in the original Cosmos series, Sagan said something that seemed like fantasy at the time. The search for extraterrestrial life is the search for a cosmic context for humanity, a better understanding of who we are. In the coming decades, I expect we will have the technology to detect planets around other stars. Remember, this was 1980. We had 0 confirmed exoplanets. The technology to detect them barely existed. Most astronomers thought it would take centuries, if it was even possible at all. But Sagan saw the trajectory. He understood that improvements in telescope sensitivity, spectroscopy, and computer processing would make exoplanet detection inevitable. He predicted not just that we would find them, but how we would find them, by detecting the wobble of stars as planets orbit, or by measuring the dimming of starlight as planets transit in front of their suns. Both methods are exactly how we've discovered over 5,000 exoplanets. But Sagan went further. He didn't just predict we'd find planets. He predicted we'd analyze their atmospheres. He predicted we'd search for biosignatures, chemical combinations like oxygen and methane that, in certain proportions, suggest biological activity. In his 1994 paper in Nature, Sagan and his colleagues analyzed Galileo spacecraft data of Earth as if it were an alien world. They identified oxygen, methane, and other gases. They detected the red edge of vegetation. They concluded This planet shows signs of life. Why did they do this? To create a template for how we would one day analyze exoplanets. And that's exactly what we're doing in 2026. JWST is analyzing the atmospheres of potentially habitable exoplanets, looking for those exact biosignatures Sagan described. PLATO will identify thousands more candidate worlds for this analysis. Sagan saw it coming, not the specific missions or instruments, but the scientific trajectory. The inevitable progression from finding planets to analyzing planets to detecting life on planets. Let's talk about Europa. In the 1990s, as the Galileo spacecraft orbited Jupiter, Sagan became increasingly excited about Europa. The data suggested a massive subsurface ocean, more water than all of Earth's oceans combined, kept liquid by tidal heating from Jupiter's gravity. Sagan wrote extensively about Europa as a potential harbor for life. Not surface life. The radiation environment is too harsh. But life in that dark ocean, around hydrothermal vents, similar to the ecosystems we find in Earth's deepest oceans. He advocated passionately for a dedicated Europa mission. In his final months, weakened by cancer, he was still writing letters, making calls, pushing NASA to prioritize Europa exploration. He never lived to see it approved. But in 2026, Europa Clipper is en route, carrying instruments that will measure the ocean's depth, composition, and chemistry. It will search for plumes of water erupting from the surface, potentially sampling the ocean without even landing. This is Sagan's vision made real, a mission he fought for, based on scientific reasoning he championed, now speeding toward a world he believed could harbor alien life. And here's what's poetic. If Europa Clipper finds evidence of life, even just organic molecules or chemical disequilibrium suggesting biology, it will vindicate Sagan's insistence that life is probably common in the universe, not rare. Now let's discuss SETI, the search for extraterrestrial intelligence. This was Sagan's passion. He co-founded the Planetary Society partially to support SETI research. He argued that if technological civilizations exist elsewhere, they might be broadcasting signals, intentionally or unintentionally, that we could detect. For decades, SETI listened for radio signals. It's still doing that. But in 2026, SETI has evolved exactly as Sagan predicted it would. Modern SETI doesn't just search for radio, it searches for optical laser pulses. It analyzes exoplanet atmospheres for industrial pollutants, chlorofluorocarbons, nitrogen dioxide, that would indicate technological activity. It looks for waste heat from massive engineering projects. It examines stellar light curves for anomalies that could indicate megastructures. This is called technosignature science, and it's a direct evolution of ideas Sagan explored in his writings and conversations. In Contact, his novel published in 1985, Sagan imagined detecting an alien signal embedded with mathematical patterns and technological information. He predicted international cooperation and debate about how to respond. He predicted public fascination mixed with fear. And here's what's extraordinary. In 2026, we have algorithms analyzing SETI data using machine learning, capable of detecting patterns that human analysts would miss. We have international protocols for what to do if we detect a signal. We have public engagement through projects like Breakthrough Listen. Sagan foresaw the shape of modern SETI, not in specific details, but in its essential structure and challenges. One of Sagan's most profound predictions was about what he called comparative planetology, the idea that we can only truly understand Earth by studying other worlds. He argued that by studying Venus's runaway greenhouse effect, we'd better understand Earth's climate. By studying Mars's lost atmosphere, we'd learn about atmospheric retention and loss. By studying Titan's organic chemistry, we'd glimpse the precursors to life. This was a radical idea in the 1960s and 70s. Planetary science was often dismissed as esoteric. Why study dead worlds when we have Earth to understand? But Sagan insisted, Earth is one data point. To understand planetary processes, we need many data points. Different temperatures, different atmospheres, different histories. In 2026, this is foundational to climate science. Our models of Earth's climate are validated against Venus, Mars, and Titan. Our understanding of atmospheric loss comes from Mars. Our knowledge of prebiotic chemistry comes from Titan and comets. The Dragonfly mission, scheduled to launch to Titan in 2027, is a direct descendant of Sagan's vision. It will explore an alien world rich in organic molecules, searching for chemical processes that might lead to life. Sagan predicted that studying Titan would revolutionize our understanding of how life begins. We're about to find out if he was right. But Sagan's predictions weren't just about specific discoveries. They were about the philosophical transformation that comes from cosmic knowledge. He predicted that as we found more exoplanets, especially Earth-like ones, it would change how we see ourselves. We'd realize Earth isn't special in its physical properties. There are billions of similar worlds. What's special is that we're here, conscious, asking questions. He predicted that discovering life elsewhere, even microbial life, would be the most profound scientific finding in history. It would answer the ancient question, are we alone? And force us to reconsider our place in the cosmos. He predicted that failing to find signals from other civilizations, despite searching, would also be significant. It might suggest that technological civilizations are rare or short-lived, or that we're among the first. Each possibility carries profound implications. In 2026, we're living in the tension of that prediction. We've found thousands of planets but no confirmed life. We've listened for signals but heard only cosmic static. What does this mean? Are we early? Are we rare? Are we not listening correctly? Sagan would say, keep searching. The absence of evidence is not evidence of absence. The universe is vast and we've only just begun to look. Let me share something specific that gives me chills. In 1994, Sagan gave a lecture at Cornell where he speculated about the year 2020 and beyond. He predicted, we will have space telescopes that can analyze the atmospheres of distant planets. We will have detected hundreds, maybe thousands of planetary systems. We will have returned samples from Mars. We will have probes exploring the outer solar system. And we will have taken the search for life beyond Earth from speculation to rigorous science. Every single one of those predictions has either happened or is happening now in 2026. JWST analyzes exoplanet atmospheres. We've confirmed over 5,000 exoplanets. Mars sample return is in progress with Perseverance's cached samples. Europa Clipper and Dragonfly are exploring the outer solar system. And astrobiology, the science of life in the universe, is a legitimate, well-funded field. Sagan saw the trajectory because he understood the technology curve, the funding patterns, and the unstoppable human drive to explore and understand. But here's what makes Sagan's predictions even more remarkable. He also predicted the obstacles. He warned that space exploration funding would always be precarious, dependent on political winds. He warned that public interest would wax and wane. He warned that we'd face setbacks, failures, even tragedies. And he was right about all of that too. Space exploration in 2026 is better funded than in the 1990s, but it's still a tiny fraction of national budgets. Public interest surges with dramatic discoveries and fades during gaps. We've had setbacks, delayed missions, failed landings, budget cuts. But Sagan also predicted something else, that despite the obstacles, exploration would continue, because it's not optional, it's part of who we are as a species. We are a way for the cosmos to know itself, he famously said. Exploration isn't just something we do. It's an expression of the universe's own self-awareness. Now let's talk about some specific 2026 discoveries that Sagan would have loved. First, the continued revelations from JWST about early galaxy formation. We're seeing galaxies that are more massive and more structured than our models predicted at such early cosmic times. This suggests that galaxy formation happened faster and more efficiently than we thought. Sagan would have been fascinated by this. He always emphasized that the universe surprises us. That our models, however sophisticated, are provisional. That nature is cleverer than we are. He would have used these discoveries to illustrate a point he made constantly: scientific humility. We don't have all the answers. We probably don't even have all the questions yet. Second, the growing evidence for subsurface oceans on multiple moons, not just Europa, but also Enceladus, Titan, possibly Ganymede and Callisto. The outer solar system is looking increasingly like a collection of water worlds. This multiplies the environments where life might exist. Sagan predicted that life would be found in the most unlikely places if the basic conditions, liquid water, organic chemistry, energy sources, were present. The fact that we're finding those conditions on multiple worlds in our own solar system suggests they might be common throughout the universe. That's a profound shift from the 20th century assumption that life requires an Earth-like planet. Third, the advances in detecting and characterizing nearby exoplanets, especially those around red dwarf stars like Proxima Centauri and TRAPPIST-1. These are the nearest potentially habitable worlds. Some are close enough that we might one day send probes there, not in our lifetimes, but perhaps in the next century. Sagan wrote about interstellar travel extensively. He was skeptical of faster-than-light travel but optimistic about slow, multi-generational missions or tiny probes accelerated by lasers. The Breakthrough Starshot project, which aims to send tiny light-sail probes to Proxima Centauri, is exactly the kind of approach Sagan would have endorsed. Ambitious but technically feasible. Long-term but achievable. Fourth, the revolution in time-domain astronomy, watching the sky continuously for changes. The Vera Rubin Observatory will detect supernovae within hours of explosion, track asteroids as they move, and find rare transient events we've never observed before. Sagan loved the idea of the universe as dynamic, not static. He talked about cosmic evolution, stars being born and dying, galaxies colliding, black holes feeding. Modern time-domain astronomy is revealing that dynamic universe in real time. It's the universe as a living, changing entity, not a frozen snapshot. But perhaps the most Sagan-esque development in 2026 is this: the democratization of cosmic knowledge. JWST data is publicly available. Citizen scientists contribute to exoplanet discovery through projects like Planet Hunters. Anyone with internet access can explore Mars through rover images or navigate the solar system through NASA's Eyes on the Solar System. Sagan believed passionately in public science education. He wanted everyone to feel ownership of cosmic exploration, not just scientists. He wanted kids in every country to look up at the stars and think, we're exploring those. In 2026, that's more possible than ever before. The barrier between professional astronomy and public engagement has never been lower. Of course, Sagan would also point out what we haven't achieved. We haven't found definitive evidence of life beyond Earth. Not yet. We haven't detected a signal from an alien civilization. Not yet. We haven't sent humans beyond low Earth orbit since 1972. We're planning to return to the moon, but it hasn't happened yet. We haven't solved the existential threats he warned about: climate change, nuclear weapons, environmental destruction. Sagan was an optimist, but not a naive one. He understood that progress is uneven, that we can make great strides in cosmic knowledge while struggling with earthly problems. But he also believed that cosmic perspective helps with earthly problems. That seeing Earth from space, that pale blue dot suspended in a sunbeam, reminds us of our fragility and our unity. He predicted that space exploration would ultimately make us better planetary citizens, more aware of our place in the cosmos, more committed to preserving our world. Is that happening? In some ways, yes. Climate science is deeply connected to planetary science. The overview effect, the cognitive shift astronauts experience seeing Earth from space, is real and powerful. Environmental movements often use cosmic imagery to illustrate Earth's uniqueness and vulnerability, but we still have far to go. Sagan would say, knowledge alone isn't enough. We need wisdom. We need to act on what we know. Let me end with one final prediction Sagan made that we're still waiting to see fulfilled. In his novel Contact, and in many of his writings, Sagan imagined the day we make contact with another civilization, not through invasion or conflict, that's Hollywood nonsense, but through a signal, a message, evidence that we're not alone. He predicted that day would be transformative, not just scientifically, but philosophically, culturally, spiritually. It would force us to reconsider who we are and what it means to be human. It would prove that intelligence, consciousness, and curiosity aren't unique to Earth, that the universe creates minds capable of wonder and understanding. It would mean that we're part of a cosmic community, even if that community is separated by vast distances and timescales. We haven't made that contact yet. In 2026, we're still listening, still searching, still hoping. But every new exoplanet we find, every new world we explore, every new technique we develop brings us closer to answering that ancient question: are we alone? And when we finally have an answer, whether it's yes, we found life, or no, we're still alone but we've searched thoroughly, it will be a moment Sagan anticipated and prepared us for, because he understood that the search itself is transformative. That asking the question changes us, regardless of the answer. Carl Sagan saw 2026 not in specific detail, but in broad strokes. He saw a humanity that had expanded its cosmic vision, that had the tools to search for life beyond Earth, that had begun to understand our place in the universe. He saw the challenges we'd face: funding constraints, public skepticism, political obstacles. But he also saw the triumphs, the discoveries that would inspire, the knowledge that would accumulate, the cosmic perspective that would gradually transform how we see ourselves. And he saw us standing where we are now, on the cusp of answering profound questions that humanity has asked for millennia. Are we alone? How did life begin? What is our cosmic context? Where do we fit in the grand story of the universe? These aren't just scientific questions. They're philosophical, existential, deeply human questions. And in 2026, we have the tools to pursue answers. Not final answers, perhaps, but real, substantive progress toward understanding. That's what Sagan predicted. That's what he fought for. That's the legacy he left us. So as we watch JWST reveal the early universe, as Europa Clipper speeds toward an alien ocean, as PLATO hunts for Earth's cousins, as the Vera Rubin Observatory maps the changing sky, as SETI continues its patient search, we're living in the future Sagan envisioned. A future where cosmic exploration isn't just possible but routine, where asking what's out there is a legitimate scientific question with serious funding and sophisticated tools, where the search for life beyond Earth has moved from speculation to rigorous science. We're not done. We've barely started. The universe is vast beyond comprehension, and we've only examined the tiniest fraction of it. But we're on the path Sagan mapped out for us. We're asking his questions, using methods he pioneered, inspired by a vision he articulated better than anyone before or since. And when we finally make that breakthrough, whether it's detecting biosignatures on an exoplanet, finding microbial life in Europa's ocean, or receiving a signal from a distant civilization, we'll be fulfilling a prophecy Sagan made not through mysticism, but through rigorous scientific extrapolation. He saw where we were going because he understood where we'd been and the unstoppable momentum of human curiosity. The cosmos beckoned, and Sagan knew we would answer. In 2026, we're answering louder and more clearly than ever before. Thank you for joining us on this journey through Sagan's predictions and 2026's cosmic revelations. This has been Echoes of Cosmos. Remember, we are made of star stuff. We are a way for the cosmos to know itself. And the discoveries we're making right now are the cosmos coming to know itself more fully. See you in the stars.